Welcome to David Alexander Maths Tuition. This is chapter 13G on areas between curves and lines. So for this question we've been asked to find the area of the region bounded by the curve and the line y equals 6. So we are working out this area here. So what we can do is we can work out the area that is bounded by the x-axis and the curve, and then we can subtract the area of this triangle, or we can see it as subtracting the area that is under the line. So first of all, what is the equation of the curve? So y is 7x take away x squared. So what I need to do is it's the integral of 7x minus x squared between the limits of 6 and 0. So that would be me working out this area here and the bit underneath the line y equals x. Minus, so I could work out the area of the triangle, but I can also integrate x dx between 6 and 0 as well. Now what I can do, I can just combine the two together. So that is the same as 7x minus x squared minus x between the limits of 6 and 0. In other words, 6x minus x squared. So let's integrate this. So that is going to be 6x squared over 2. So that is going to be 3x squared minus x cubed over 3. And that is between 6 and 0. Now when I put 0 through this, I will end up subtracting 0. So my answer is, the area of the region that we're interested in is literally just substituting 6 into this equation. So that's 3 times 6 times 6, take away 6 times 6 times 6 divided by 3, and that is 36, take away 0. So this area here is 36 units. Okay, so knowing that you can, depending on the question of course, is just subtract one integral from another and then just sort of combine them all together, makes life a lot easier. But as I said, we could work out the area under this curve, the area under this line, and then subtract one from the other. And again, this area here we can work out using integration, or we can just simply do base times height divided by 2. So 6 times 6 halved, so that's got an area of 18, and subtract that from the area underneath the curve between 6 and 0. So a couple of ways you can do that question. Okay, let's look at another example. So we want to find the area bounded by the x-axis, the line y equals 3x, and the curve. Okay, so this is this area here. So sometimes it's just worth thinking of the strategy. So what I can do is I'm going to work out the area under the line y equals 3x, and then I'm going to subtract this slice here. Okay, so what I'm going to do is this is going to be the integral of 3x, and this is between 7 and 0, and I'm going to subtract the integral of, so this is x squared take away 4x, but this isn't between 7 and 0, this is just between 7 and 4. So we just need to be careful with our limits here. So let's have a look at, let's integrate 3x. That's going to be 3x squared over 2 between the upper limit of 7 and lower limit of 0. Take away, this is going to be x cubed over 3 minus 4x squared over 2. So take away 2x squared, and that will be between 7 and 4. Okay, so when I put the 0 through this, that will be minus 0. So there's only one calculation here, which is 3 times 7 divided by 2, which is 147 over 2. So the area of this triangle, again I could have worked this out using base times height divided by 2 of course, is 147 over 2. So let's just get rid of that minus 0 there. Okay, so and from this I need to subtract the integral, or this definite integral. So I'm going to do 2 brackets inside a bigger bracket, because remember I need to subtract the whole thing from the 147 over 2. So first of all I'm going to put 7 through the function, so 7 times 7 times 7 divided by 3 minus 2 times 7 times 7, so that is 49 over 3. and now put 4 through it, so it's 4 times 4 times 4 divided by 3, take away 2 times 4 times 4, which is minus 32 over 3. So 49 over 3 plus 32 over 3 is 27. So all of this comes to 27, so the area is 147 over 2, take away 27, and 147 over 2 minus 27 is 93 over 2, or 46.5 units. So this area here is 46.5 units.